Okay, I hope everyone can hear me. So we have 10 days and we are going live now. First of all, I welcome you all to the first webinar on Jumpstart to Data Analytics, hosted by Microsoft Developers Community Odisha in association with IndiaMentor. Thank you all for joining us today. I am Saurav from MSTC Odisha, and I'm really excited to be the moderator for this webinar. Today, what do we have for you about the session? We expect the session to last about 30 minutes, and after that, we will follow the question and answer round asked by our participants. We'll try to answer the maximum number of questions as we can. If we fail, then we'll definitely revert back to you. So today, it gives me a great pleasure to introduce our guest speaker, Mr. Ankit Mohanty. He is an alumni of KT University, Bhubaneswar. He was a founding member of our community, MSDC Odisha. He is a blogger, coder. He was an MSP for 2 long years. He got placed in Mu Sigma in 2015, and he worked there for a year and 4 months. After that, he joined Google. And from last 9 months, he is currently working at Google as a data scientist. So over to Ankit Mohanty now.
Hi everyone. First of all, thanks Saurav for that introduction. I mean, I think he spoke a lot about me, but that being said, just give me like some 30 seconds so that I can check my setup and so that the next half an hour of yours or 1 hour of yours goes fluidly as possible. Okay, looks like the setup's done. Two things before we start off with the webinar. These are a few technical things which will ensure that we kind of have a very good session for the next 1 hour. So all of you participants would be able to see the control panel, which is the GoToWebinar control panel. Now, a few things here. If you want me to interrupt in between of the presentation, there's an option for you to raise your hand, which you can see as a hand gesture right in front of your name. Then if you are asking me questions, you can leave me questions on the question panel, which is there again on the control panel. Post the presentation, which I hope would last for some 25-30 minutes. Sorry to bore you guys. I mean, yeah, I can understand it's evening, Saturday evening, but thanks to all of you for joining in the first place. So if you have any questions, I'll be answering them for sure. Also, post the presentation, we would be pausing for 5 minutes where I would give you the put down all the questions on the panel so that I can go through them one by one and answer the most number of questions today. If it sounds good, then I'll start. Okay, so this session is mostly for beginners because I'm assuming that most of you are not into data analytics right now. But again, I mean, this session would be helpful for people who are in the industry because this is perspective of what I have learned as a last 2 years. Because as I studied university and data sciences, my background is a little bit different from what you would expect given the profile that you just heard. Because, like, in my childhood, I used to love biology, so I took up biomaths, then I took up electrical, and now I ended up becoming a data science. So this session is mostly what my perspective is about this industry and how you can think of a career, how you can jumpstart your career in this industry. Because today everybody is doing data science. It's kind of a thing which is getting. So we'll start off with before that, my first question to all of you would be, how you assigned the analytics domain? Answer that. If your answer is yes, if you can just raise your hand, that would give me a sense, how many of my attendees are today versed with what this world is. So if you are in the data science industry, I give you not the same, which I would clear in the due course of time. So yeah, I'll show you one of the cartoons which I closely related to when I kind of joined this industry. So if you see this cartoon here, it is a setup of 4 people in an organization where they are talking about tons of data which they have with them, but nobody apparently in the panel has any clue of what to do with the data. Now, why I have put up this cartoon here is because let's just take an example of when you go to a website, you sign up there, you fill in lots and lots of information, first name, last name, gender, age, like lots and lots of information are being filled in there. Just imagine the company which is taking all of your data. Just imagine the amount of data they're collecting and the ways by which they can help themselves with the data. The issue here is they are collecting the data in the good way that they can, but what they're failing to do is they don't have an analyst, they don't have a data scientist, they don't have a decision maker to make decision out of the data. Now, Harvard Business Review around in 2015, I believe, if I'm not wrong, declared data science as the sexiest job of the 21st century. And it's not because of the name that you're hearing, because there are lots and lots of fancy names in the industry. You start applying for companies, you would hear decision scientist, you would hear data scientist, you would hear machine learning ninjas, you would hear business analyst. All of these are fancy names, but the core of the work remains the same. Now, Harvard Business Review was of the view 2 years back that data sciences is going to be the biggest industry in years to come. And I would show you how the numbers are looking today, because there's a grave shortage of people in this industry right now. So yeah. Now, I'm pretty sure this is the basic question that you all guys would be having, because everyone today here say I'm a data analyst, I'm a data scientist, and all of those. But what is a data analyst? Who is a data analyst? Now, the slides which follow from this slide onwards are all my views. I mean, you wouldn't find them in dictionaries, you wouldn't find them on websites, you wouldn't find them on all these tutorials and everything. This is what personally I have learned, that what according to me is a data analyst. So data analyst is essentially a combination of 4 things. I would start off with the green bar here, which is the mathematics branch of data analytics. So you take mathematician, you take somebody who's good at delivering presentations, somebody who knows how to make sense of the data, somebody who knows how to derive insights from the data, merge them along with the skill sets of a person who's very good in computer science, or if not very good, who's at least very good in writing logics, and then add to it tons and tons of experience of real life business problems. All of these factors come together and make somebody a data analyst. Now, don't get worried. I would be jumping into all of these individually as to why, according to me, all of these branches are essential in making you a data analyst or a data scientist. Yeah. So now let's take an example. of the same cartoon that we just saw in the previous slide. So you have a business problem. Your CEO, your CTO, CFO, whosoever XYZ the person is, comes to you and tells you that, hey, we want to launch a marketing campaign in this area. And he wants you to find out what would be the segment of market that you need to target, what would be the valuation of the product, and n number of business questions like those. Now, for somebody who's not into data analytics, what would be their approach be like? You would find out the data, you would do surveys, and then you would find out like the average amount, like the average expenditure of a person. You would find out what the economy is and all of these things. And then you would come out with a conclusion saying that, hey, I think the product can be priced at X amount and we need to spend X, Y amount of money on the marketing campaign. Now, this is where a data analyst will be different from a normal approach that I just spoke about. So put in a data analyst into this situation. And now I will explain to you how all of these branches would come together and make that data analyst the correct person to answer the questions asked by the company. So imagine somebody is a data analyst. He is given the problem. From the mathematics angle of the problem, how would he think of the problem? So the first thing that he would do is ask lots and lots of questions, because as a data analyst, your first target should be to understand what the problem is. And to do that, what better way rather than asking lots and lots of questions? And let me tell you something which I've observed in the last 2 years. Data analysts, by virtue of their job, tend to ask a hell lot of questions, because of which when we go to webinars, when we go to sessions of data analytics, when we go to exhibitions, when we go to all of these events, it's always seen that people keep on asking questions because that's what their job demands. So particularly in this situation, there would be n number of questions being asked by the data scientist, and answers to which would be a mathematical figure for most of the times. Because if you can't quantify something, it gets very problematic for you to approach the problem. Agreed, there can be situations where the problem is very vague, it's qualitative in nature, but then good data analysts, good data scientists transition those qualitative aspect of the problem to quantitative aspect of the problem. So now in terms of mathematics, if I just tell you that, okay, there are 10 people in the class and find me what the average of the heights would be, which is a pretty straightforward thing to answer. So which I'm pretty sure every one of us would be doing if we are not exposed to the industry of data sciences. Because as kids, when we are taught in school, average is one of the basics things and one of the most used things that we are taught in the school life. Whereas give a data scientist or a data analyst into this situation, what that person would do is he would first segregate all of these population. Like let's say there are 10 people in the class, he would segregate them by gender, he would segregate them by age group. Because if you just tell me that the average of the heights is, let's say, 5'5" that is giving me an information, correct, but that is not revealing to me the entire picture. Like what business judgments would I take from those data? So as a data analyst, that person would maybe first like slice the data in terms of male female ratio. He would then look at what the age group is, and for all of these categories is what he would give me the average to be look like. Because there can be a difference, like maybe that the people who are in age, and it's for certain, right, people who are growing tend to have a larger height, and then people who are like in the teenagers will always be obviously having shorter heights, right? So that is how a data analyst approaches a problem from a mathematical term. Now, why art? Okay, before even we jump into art, let's look at the computer aspect of it, because this is a very general question which I have been getting for a lot of time now, that hey, we want to switch to data analytics because we studied computer science and we don't think that we are pretty good at coding, which people think that is tough. So we might just want to switch to data analytics. So tell me, how can I switch to data analytics even though my computer coding skills is not that good? This is a very common question which everybody has asked me in the past 2 years. The answer to that is data analytics requires coding for sure. I wouldn't deny that it will happen without you not writing any piece of code. But what you guys need to understand is, as a data analyst, you would be analyzing data, millions and millions of data. And when you write codes, it wouldn't be for creating a software. That is very different. As software developers, people are creating something. Just think in those directions. When I ask you to create something, it may be as simple as a PowerPoint presentation. Imagine the amount of effort that you have to put in. Whereas think of writing codes to just analyze something, just to like kind of slice the data into pieces. Those are completely two different things. So yes, you can become a data analyst if your coding skills are not that good. But again, that being said, there's a branch of data science which requires very good amount of coding, very good skill set coding also, which we would look into eventually. But as beginners, trust me, you don't have to be like a killer software developer or a killer coder or a competitive programmer or things which you hear of in day-to-day life. You can get started without having any prior experience or expertise in the field of computer sciences for a beginner in data analytics. So that is how computers is useful. Now, why art? Okay, so you are very good at slicing the data. You are very good at using formulas like mean, median, mode, which we generally use and which we generally hear of. You are very good at all of these things. You can calculate, like if I give you some millions and millions of rows of data, maybe you can use database management systems, SQLs and all to write queries and to find out programmatically what the mean is, what the median is, and all of those. You would be very good at that. But imagine these are all business questions that your CTO, CFO, or the CEO has asked you, and they have absolutely no expertise in data sciences. For them, what makes sense is the ultimate figure. Now, how do you explain what the figure is? You would analyze lots and lots of data, you would come up with lots and lots of results, but which results to cherry pick for your CEO to understand? Because that poor guy has no idea of what your analysis is. As a data scientist, you are very experienced and you find out all the data and you just put it on a paper or on a whiteboard and tell your CEO that, hey, look, this is the number. But probably that guy wouldn't understand, because the insights that you had, the thought process that you had in your mind while solving the problem has to be portrayed, has to come out from you and get into the minds of the person who's asking you the business problem. That is where art comes into picture. You really have to be a person who can explain the solution in the very good manner rather than be a champion at finding what the solution is. Because today, believe me, we have lots and lots of people who can find what the solution is. The shortage is of people who can explain that solution very proficiently to people who have no idea of what that solution is. So that is where art comes into picture. And now, which is the last bit, is experience, which is kind of, I'm talking about data analysts as beginners, and then I'm talking about experience, which I am pretty sure isn't making sense to any one of you. But yeah, experience does matter a lot, because the more number of problems you solve, the more variety you have in your approach. And there are lots and lots of problems being solved right now. Like, it would be hard for you to believe maybe that Bangalore traffic police has employed one of the data sciences company to solve their traffic problems. So you need lots and lots of experience, and you need experienced people in the team to help you navigate through those ambiguous problems. So all of these, maths, arts, computers, and experience, when come together, is what make a very good data analyst, at least from my point of view. Okay. Now coming to the first thing that I mentioned, that I would be heavily using data analyst / data scientist in this entire course of presentation. I would clear that out. Like, what are the different careers that is there in the data industry right now? So there are three things. First is data analysis, which is a primary work of the data analyst. So consider data analyst to be the starting position in your career. Like, you have business analyst, you have senior business analysts. So consider data analyst to be the beginning position of your career in data science. So what data analysts do? Data analysts in an organization are mostly given the work of identifying patterns in the data, identifying what the data is trying to tell the company, identifying what data do you require from the customer, and then analyzing upon all of these things to come up with kind of insights which can be taken action upon. Because I might say that, okay, 100,000 people in Hyderabad want to have mango, which is definitive of the fact that, okay, there is a demand for mango sale in Hyderabad. But consider me telling you like there is a requirement of like as ambiguous a statement like there is a requirement of mangoes in Hyderabad. Now you have absolutely no clue how many mangoes are required, how many people would be having those mangoes. So this is how a data analyst comes into picture. You would be the one as a data analyst asking the correct set of questions and then using data to answer those correct set of questions. And once that is done, delivering those answers in forms of actionable items to your organization. So that is where a data analyst comes into the picture. Now, what are data scientists? Who are data scientists? Data scientists consider, according to me, data scientists can be considered like the mid-range of people who have done their masters in analytics, who have done their masters in computers, or who have certain amount of expertise into the field, and they can navigate this problem completely alone and they can give you a solution. So data scientists are kind of the middle rung of the ladder who have expertise clubbed with their experience. So that is what makes a data scientist. So as data scientist, you can maybe go talk to your engineering team and even tell them that, hey, your algorithm is not working. I think this algorithm might work. So as a data scientist, your suggestions would be heard. Whereas when I just spoke about data analyst, by virtue of you being a fresher into the industry, you wouldn't be having so much of knowledge and so much of expertise into altering the algorithm or altering the way things are presented to the customers and all of those things. So this is how at least data analysts and data scientists differ in nature. Now there's a third branch also, which is in growth right now, particularly in the last 2 years, there has been a surge. So this branch is for data engineers. Now companies are collecting data. It could be organized, it could be non-organized. So when I say organized data usually means all those forms that you fill in while signing up on whatever website. Whereas unorganized data is, think of Twitter, all the tweets which people put on Twitter. Just imagine how great it would be for somebody to understand what the sentiment of a particular city is at a given point of time. So you can use Twitter data to analyze sentiment of people. So that is where data engineers come into picture, because as data engineers, you would be given the task of maintaining the databases. You would be given the task of designing such databases which can expand, which can scale with the velocity and the volume of data that flows into the system. So data engineering is, for like, as per my understanding, data engineering is kind of an extension to what software developers are, because we have been having these kind of people for the past few years now. We have database administrators in almost every IT organization. So consider this branch to be an extension of that particular thing. Just that as a data engineer, you would be heavily focusing on maintaining the data, creating the data, managing the data. So this is what a data engineer looks like. Okay, proceeding. Now there's a reason I have put on the screenshot. If you just go to Google and type how to become a, which would give you lots and lots of things like how to become a computer engineer, how to become a coder, and all of those things. But just add a space and add the alphabet D and see in today's time what is the second suggestion by Google: how to become a data scientist. Which is kind of the very reason I wanted to put this thing here, is because I wanted you guys to realize that data science is on a surge right now. Lots and lots of people want to become data scientists. And specifically, let's talk about India. You wouldn't get a degree of data sciences in India until and unless you are looking for a master's degree, because there are a few master degrees available in India right now which give you the degree of data scientist. But on a bachelor's level, I doubt there is any college today which is even having a curriculum for data sciences. And this is what is creating the shortage. So primarily, I understand all of you would be interested in knowing how to jumpstart your career, because essentially this is what the session is about. This is what the put down all which I have learned in the past 2 years and which are a critical must for anybody who wants to jumpstart their career in data sciences as a data analyst or as a data scientist. I just mentioned a few slides ago. So now programming skills of a data analyst totally differs from a programming skills of a software developer, because the fact remains the same. They are creating products for you and you are utilizing those products to write codes and algorithms. So the very first basic thing which according to me is an essential must is good query writing skills. And for that, it's like now one of the world standards. So SQL is one of the world standards when it just comes to data analysis. Every other person in the industry has or is using SQL for their data analytics. Now the second thing which is important is SQL, but it is way more robust, way more fast, and has been made typically to manage large scale, huge scale data. SQL depends on the infrastructure of your organization, depends on what the data engineer guys have done with your data. SAS is way more robust in those terms. You can write good amount of code and execute them in one go, whereas maybe in SQL you would have to modularize that code, and every code's output would be some other code's input, whereas that necessarily is not the case with SAS. SAS helps you deal with millions and billions of rows of data in one go. uh, Again, provided the infrastructure has been set up in the first place, because SQL for you as a fresher, it would be very easy for you to kind of use any SQL distro that you want and work upon any sample data that you have. Whereas SAS is totally your enterprise software. Like, I know companies pay lakhs and lakhs of rupees for just getting the license of SAS. So you wouldn't get to use SAS until and unless, kind of go into a very large company which uses data analytics in a very good way, because those are the companies which tend to pay the money for SAS. Now, the biggest competitor of SAS in those terms is R. So I think most of you would have heard about R programming, because now that even Microsoft is openly supporting R with integrating that into Visual Studio. So R has become a very big thing in the past 5 years. So R is kind of open source, whereas SAS is not. So this is the basic difference between SAS and R. R, because of being open source, people have created packages just like NuGet packages, which you find in Visual Studio. People have created packages for use by others, which is hosted on an online library. So you might think of any problem, and as a fresher, you would be exploring a lot and you would want to solve a problem. R has a very good community of people where the chance is high that the problem might have already been solved by someone, and you can use that thing to build upon the problem and then give your own unique solution. So my my advice to every one of you who wants to have a career in data science, start off with SQL and R and just forget about SAS, because SAS you would eventually use when you come into the industry. But SQL and R should be the basics that you should know when you are thinking of beginning a career in data sciences. Python is for it sits between the data analyst and the data scientist branch. It's kind of for people who have had some good amount of experience in data science and now they want to expand the scope of problems that they are solving. So Python, they would be using it in those situations. So my advice is, don't look out for Python as a learning idea when you are just beginning a career as a data analyst. You can learn that very easily after maybe 1 or 2 years of into the industry, after you have been in the industry. So yeah, Python I've just put in here because it's one of the things that we use in data sciences, but it's absolutely not a must for you to kind of learn Python, and it's not even a requirement for most of the jobs. So yeah, you can leave Python. T3.js is a visualization library. It's for, because when I was mentioning for somebody to be a good data analyst, it's a requirement that you kind of explain what your solution is in a very well manner to others. D3.js is one such thing which would enable you to do this. So in d3.js, you can host websites, you can create like dynamic graphs, which you can host on a URL and then give this link to anybody in your organization to view. So just imagine charts in Excel, charts in PowerPoint, which you have been using for long. All these charts come in a web browser and make it look even more appealing. So like, if you guys have seen all of these political coverages by the New York Times or by any of the Indian news channels during our prime minister election, during our assembly elections. So you see all these fancy graphs, right? Like a speedometer graph depicting where the votes are going to, like bar charts, and all of these waterfall diagrams where you kind of see branches coming out of a main branch. So all of these are most of the times done in d3.js and hosted on a website. So, and this, the very reason I've put it on the very last of this list is because d3.js should be your last priority. First of your priority should be learning of SQL and R, because d3.js comes into picture when you want to visualize your data. And there could be chances that you might not even require visualization of your data. So yeah, my advice is keep d3.js and Python for the later stage of your learning curve. Now that is what, according to me, is at least required, like the basics, which things are required in the programming branch of a data analyst. Now let's come to the statistics part of it, which is the corresponding branch of mathematics. So without statistical understanding, life as a data analyst would be very, very troublesome for you, because we humans, we people who have taken up science and maths are very good at finding out average and then reaching out to a conclusion that, oh, okay, the average looks like this. So it's good to say that based on the average, this is what our assumption is and this is what our recommendation is. Trust me, there's a big and a vast world apart from average. And there are n number of examples which currently are out of the scope of this discussion, because if I start talking about it, it will take up the entire time. There is a world beyond average, and in most of the situations, like 99% of the time, average wouldn't give you any actionable insight at all. Like average are absolutely not helpful while taking business decisions. So that is when these two branches of statistics come into picture, the descriptive part and the inferential part. I would give you a brief intro into what these things are. So when I said average, this is part of descriptive statistics. So what descriptive statistics is, you have a data, you are finding out mean, median, mode, you are finding out the average, you are finding out distribution, which we studied in our first year of college or in the 10th and 12th standard. So all of this becomes a part of descriptive statistics. And why the word descriptive? Because you kind of are describing what is already there in the data, just using mathematical formulas for those descriptions. So this is what descriptive statistics is. I'm not saying that that is absolutely not required. Even that is required in scenarios, because that is what will give you the starting point in the first place. So descriptive statistics is absolutely a must. But what is more important, what would make you a better data analyst is strong understanding, or at least a good amount of starting understanding of inferential statistics. So what is inferential statistics now? Inferential statistics, okay, let's focus on the word inferential. So inferential is essentially taking out inferences from your data, and that is absolutely what inferential statistics is all about. So let's say, okay, let's look into this scenario. All of us look into weather data almost every day now because it's summer, right? And we get to see that, oh, okay, today would be 44, maybe 5 days from now it would rain, maybe 3 days from now it would be very humid. How are companies giving you these data? Probably 10 years before, people used to just look at historical data and say that, okay, 6 out of 10 times it rained on this particular day. So probably the probability is 6 by 10. So they would just give you based on the probability score that, okay, it might rain today also. Whereas today, where the entire world is relying heavily on data sciences, this is where you would deploy data science in a very good way. You would be predicting based on the previous history that what is the chances that today it will rain. it wouldn't be just normal probability. It would be it would be things beyond a normal probability. So inferential statistics come into picture at that point of time. So you would be doing time series analysis, and pardon me if I'm using jargon terms because these are all new to you, I understand, but these are all terms which you would hear once you come into the industry. So you would do time series analysis, you would be doing regressions, you would be doing linear regression models, and deploying all of these to find solutions which would be predictive in nature. So this is what is the statistics branch of it. So you need descriptive statistics as well as inferential statistics. Now, I have just listed down these items, but trust me, I would be sharing these slides with you after the session, and I would ensure that I link good reading resources for anybody who wants to look up about all of these things. So yeah, don't worry about that thing. Now let's look at the presentation skills. Why did I say presentation and art make you a very good data analyst? So I remember 2 years back when I was in college, I knew nothing about data sciences. I had absolutely no idea about what data science industry is. And my introduction to data sciences happened because of an interview which I was appearing for, which was of Mu Sigma. So there, I kind of asked my seniors, I kind of read up on online sources and found out that the very first thing that they judge people on is the ability to ask the right set of questions. Because no matter how good you are at maths, no matter how well a programmer you are, if you don't ask the correct question in the first place, what would you program for? What would you use the mathematical formulas for? So you need to be absolutely fantastic at asking the right set of questions. The number of questions might be less, but even if you ask the most critical question in a team, trust me, you would be a hero. You would be no less than a hero data analyst in this industry. Because most of the times I've heard all my juniors coming up to me, all my college students who are there in the college right now and are appearing for the placement seasons, they come up and tell me that, hey, I sat for so and so data analytics company and they just rejected me without telling me anything. And my answer to them is probably you got rejected, probably you did not get selected because you didn't ask the right set of questions. Because when an interview gave you the question, you jumped into the conclusion. You didn't think about asking what other questions can I have in mind. And why do I say so? Let's say I give you a very arbitrary question, count the number of buses which are running in Bhubaneswar. And maybe a very good student who's very good at solving problems will just take a pen and a paper and find out algorithmically that, oh, okay, this bus leaves from this place, 100 people take up the bus from this place, college area might have more number of buses, not so advanced areas, developed areas might have less number of bus routes. So you are jumping into conclusions. Whereas as an interviewer, if I were the interviewer, what I would be interested in is you asking n number of questions to me, because that is how it would prove me that, okay, this person is thinking in terms of collecting data. Because the more number of data points you have, just think of it like it becomes really easy for you to answer those questions. Whereas if you don't ask me any questions, you have absolutely zero data with you. So what are you relying on to solve the problem is just your gut feeling, which is absolutely not useful in data analytics industry. So yeah, the first thing is don't rely on your gut, don't rely on your common senses or anything, just rely on your question asking ability. So that is the first point which you require if you want to become a very good data analyst. Now, data visualizations, which is obviously essential because, hey, who doesn't want to look at charts? I mean, you give me 10 numbers of 10 people saying that, okay, person A is this height, person B is this height. Whereas if you just show me a chart, it becomes so visually appealing. And even even before becoming visually appealing, it becomes very easy for me to absorb that, because human tendency it is like at the end of the day, if you see something, you tend to remember it a lot than you hear something. So that is where data visualization comes into place. Making business sense is something which, like, the industry doesn't expect from freshers much, because we know how our curriculum is. Like, I don't think anything of business apart from, I think, some entrepreneurial studies which happens in the fourth year, which is a must for people, I believe, in the UGC curriculum. I'm not sure though, but yeah, I had it. So that was the only kind of introduction for me into the business world in my engineering career. So making business sense is something which eventually happens after you solve lots and lots of problems. So don't worry about about at least making business sense as the point if you want to learn what data analytics is. You eventually would start making business sense after you understand what business is, which obviously would happen once you join the industry. Now, deck making, PowerPoint presentations. Okay, so deck making and storytelling ability are very closely coupled with each other, because as data analysts, most of the times you would realize that what you're doing is nothing but telling stories out of the data, making stories out of the data. And how do you tell those stories? You cannot do it in a narrative manner. You have to put it on presentations with your data visualization skills to come up with a very nice recommendation presentation for your company. So storytelling ability and data making go hand in hand. Like, you cannot separate them at all. So this is what, according to me, should help somebody with absolutely zero experience in data analytics to jumpstart their career. Like, follow this path, and I wouldn't ensure you that you would get a job in this industry, because I would be very frank with you guys. This industry is right now, because it has grown like manifoldly in the last 5 to 10 years, is asking for people who are experienced in this industry. So I think the landscape is changing. But again, that being said, you guys have the best opportunities of joining startups, because every single startup wants a data analyst in their room today. They want a person who can make sense out of their data. So your best possible solution to not being hired by big companies is to first start your career as a fresher in one of the startups, learn things on the go, because as I said, experience and business sense comes with once you get into the industry. So build up that profile, build your experience, enhance your business decisions making capability, and then obviously you can switch to any big company. Because I have known people who are working in large companies after they have kind of come from startups in various parts of India. Okay, now this is the most lucrative part of the entire slide. I had to put in here because it's a common thing for nowadays for freshers, because everybody wants a fat paycheck as the first paycheck. Like, gone are the days when people used to, kind of get happy with, oh, okay, I came into the IT industry, I'm earning in some X lakhs per annum. Like, I don't think anybody wants that anymore, because the pay scale has drastically grown in the last 5 years, and people obviously want to ride that bandwagon and kind of increase their first paycheck in all ways possible. So just to give you an insight, how much does a data analyst, at least in India, makes? And these figures are not representative of the world. This is an old analysis done by a very big firm. I would attach the entire report onto this presentation when I share it with you guys. So this is one of the the surveys that they did, and this is data from 2016. And yeah, the scenario is almost the same, but 2017 has again seen some increase in the pay scale of data analysts. So this data is a little old in that terms. So if you see Mumbai, and this data is sliced by the cities. So if you see 12, approximately 12 lakhs is what you would be being paid if you are a data analyst in one of the companies based out in Mumbai. And this is only your base pay. You have XYZ amount of things apart from it. Like, you join big product firms, every one of us know you might end up getting stocks, you might end up getting good bonuses and all of those. Whereas even if you join as a fresher in one of the startups, they would be giving you, and this is like the average of that city. So you would end up getting that amount of money apart from all the other benefits which you can get as a data science. So you can see the entire figure here. The least that you would be paid if you become a data analyst is in the tunes of 9 lakhs. Now, there can be outliers. There can be people who start their first salary as not so high because, like, you might have to compromise on the salary if you want a career in data analyst, because data analyst relies heavily on your infrastructure, and companies who have not that big a scale of infrastructure would eventually end up paying you less because they have to manage their costs. So according to me, it's absolutely fine if you are being paid anything less than what the figures are shown here, because once you start your career, the jumps that you would be having, and trust me, most of the guys that I know in this industry, most of my friends whom I know, the jumps that they have got in their career because of being a data analyst and starting at a low position is in the range of 200 to 300% of salary hike, which is like exponentially high across industry. No industry would give you that amount of hike today. So this was just to give you an idea of what the salary would look like if you just think of a career here. And this is one of the answers which I asked in the very initial slides of today, that how many data professionals would be required. This is a survey which was done in 2015, and they found out that close to 181,000 people would be required only in the United States as data professionals, which is, if I'm not mistaken, a 230% of increase in year over year, which is like absolutely high. You have no idea how many such requirement is in India right now. This figure is talking just about the United States, whereas India is also on the boom for the data industry. So yeah, I mean, this is the best time for you guys to start off if you think that you want a career in this field. And because 2 years from now, even this would be the requirement in India, and it would be very easy for you to get hired. So this is absolutely the right time to look for a career in data sciences. Okay, so with this, I am done. And as I mentioned, I would be giving you guys 5 minutes for you to ask questions, because I see a few questions here, but I would just mute myself. I would stop sharing my screen and would give you guys 5 minutes to ask whatever questions you have. And in the meanwhile, I would give the presentation over to Saurav. So Saurav, if you can just like take over for the next 5 minutes.
Okay. All right. Attendees, if you have any questions, then you can just click on the question section and you can type your question and click on send button. Guys, please do ask question. Okay, we have questions now. Ankit, are you able to hear me?
Yeah, Saurav. Yeah, I think we can get started and we'll give some time to other folks to kind of put in their questions. So yeah, I would be picking in questions now. Okay, I have Kamesh, who has asked me a question saying, good evening, sir. I'm a second year BTech engineering student. As a student, how should I go for the data analytics? What strategy should I take? Okay. Hi, Kamesh. My suggestion to you would be follow whatever steps which I just mentioned on the slides. I would be obviously sharing the slides with you. So that can be a reference point for you. But that is not the end of the data analytics industry. You need to learn a lot of other things. But a few good starting points for you would be to follow like data analytics blogs, follow people on Quora who are data analysts and who are data scientists, because they tend to share a lot of their experiences of real life there. And as a college second year student, I think you are absolutely on the right track, because you have like 2 years from now to kind of, if you are interested into coming into this industry, so you have 2 years to prepare, which is a good enough amount of time for you to get ready for this industry. So yeah, my suggestion would be, like, you don't need to have really any big strategies as such. You just need to be kind of learning all of these things, and just make sure that you are updated with the way this industry is growing, because one of the key aspects of this industry is it is changing year over year. Things are changing very rapidly, technologies are advancing very rapidly. So because you are in second year, it could be very possible that you start off with things which are relevant now but might get obsolete in the next 1 or 2 years. It's just a possibility. I'm nowhere hinting that that would happen, but my advice to anybody would be to keep yourself updated with the technological advancements that are happening, at least in this field. So I would be moving on to the next question. Okay, I have a question from Ashutosh Singh, who asks, what is Google and Excel Analytics? Okay. Google Analytics is a tool, is a platform extended by Google for people who create websites, for people who use advertisements on Google to analyze their data. So engineers, data analysts, software developers at Google ensure that as a product user, you are given a platform where you can most of the times drag and drop and find out what the solution is, find out what business insights you are looking into. So that is what is Google Analytics. Excel Analytics is no such thing as far as I know, because Excel is a standalone tool which is part of the Microsoft Office suite. And Excel is one of the important softwares which most of the companies, most of the startups are relying heavily upon. One, because it is cheap. Two, because it is easy to learn. Like almost all of us have had at least worked on Excel in our college life in some way or the other. Maybe it could be like for an organizing committee, or maybe to do any analysis. It depends. But every one of us is at least exposed to what Excel is. So Excel is one of the tools which you use to do data analytics. You can find out mean, you can find out average, median, mode. You can do predictive analytics, like you can feed in historical data to the Excel, and Excel has lots and lots of things, lots and lots of packages which would kind of, give you a prediction of a graph in a form of a graph, saying that, okay, the number of users might increase in this way. So Excel is one of the tools which you would heavily use for analytics. Okay, I would move on to the next question, which is from Abhijit Patnaik, who's asking, is there any online source for getting started with data analytics? Okay, Abhijit, trust me, there are so many online sources that you might just get lost. You might get lost in the vast ocean of information, because you just search, like, just go after this session, go to Google, go to any search engine, and just put in online sources for data sciences. Like the amount of links that you would get is tremendous, because this field is very new. So everybody wants to write a blog, everybody wants to put in a presentation, everybody wants to give you data to analyze, everybody wants to create sessions for you. So this, you would find n number of links. Now, how smartly you read up, you select those links, is what would define how good your understanding of this field would become eventually. And now, what do I mean when I say smartly? My rule of thumb is just follow Coursera, edX, and Udacity. All of these are massive online open courses, MOOCs, which we talk about. And just follow their websites, because they have tied up with industry leading people, and they have tied up with very good colleges in the US. And most of the times, most of the courses are free. I understand on Coursera and Udacity, the cost would be high, But at least on edX, there are lots and lots of free courses. I would share all of these links, so don't you worry about all these links and all. But edX has lots and lots of questions from Microsoft, which are completely free and which would help you get a hold of what data science is. So yeah, my advice would be to at least first of all rely heavily on edX. Okay. Okay, Ashutosh asks me a follow-up question on how Google and Excel analytics are different in what is done on SQL and R. They are not different, just that the scale is different. Excel would fail after some n number of rows. SQL and R wouldn't. So you see, the scalability is the major issue here. SQL and R, you can run codes on scale. Maybe it could be a trillion rows of data. Trust me, Excel would hang up your entire system. It could be a Mac, it could be a Surface Book, whatever device you are on. Excel, Google Spreadsheets, Office, open source Office softwares which are available would eventually hang up your machine, whereas SQL and R wouldn't. So the basic difference is the scalability part of it. Okay, I have the next question from Manzar, who asks how you prepare yourself for becoming data analyst. Okay, thanks for asking this question. I mean, I have been hearing these questions for a lot of time now, and I would give you the same answer which I've been giving for the long amount of time now. I had no clue of what data science is when I was in college, and if you don't trust me, you can ask all my members from the Microsoft community, because they have seen my learning, they have seen what I was in my college. So I think they would agree to the fact that I was nowhere related to data sciences. I always wanted to, kind of develop applications, develop softwares for people to use. That was what my passion was back then in college. It just happened that I heard of this company called Mu Sigma, which sparked my interest. And I just I didn't like the things which I spoke about in the slides in terms of what you should learn if you want to become a data science. Trust me, I had done no such thing, because I just had a month amount of time. I had just 1 month with me to prepare for the interviews, and all I knew was, okay, this is a company called Mu Sigma, which has 5 rounds of interviews, and which every round is a rejection round eventually, and they, out of some 2K people, they just end up taking 10 number of people from one particular location. Just that I had no expectations. I would be very frank with you. Like, the thing that I have been doing with myself, which I have been telling myself, and which I tell every other person who asks me, be true to yourself. Don't be result oriented, or, kind of don't demand results when you are in your starting phase of your career. Because if you have goals for you, it's very good, because now I think people would not agree with me that, hey, why shouldn't we have goals in career? You should absolutely have goals in career, but trust me, do take risks, because if you don't, you would never ever realize what your potential is. So could be that you might not be a good fit for the data science industry, but then what is the harm in taking the risk? What is the harm in learning a new thing and maybe giving it a shot? Maybe you could end up becoming the best data scientist of this country, because the lead data scientist in the United States, in the White House at least, before the Trump government came into the scenario, was an Indian guy. So you never know, you can become one of the best data analysts this world has ever seen. So do take risks. That's just what my suggestion would be. And answering your question of how to prepare yourself, I think whatever I mentioned in the slides, whatever you would be getting the links from me, those should be at least sufficient for you to get started in this field. Okay, I have this question from Tanmay, who asks, can we use data analytics for exiting sites having millions of records and only having SQL used for statistics? Okay, I probably think I'm not getting the question here correctly. Tanmay, if you can rephrase your question and kind of pinpoint to what you are asking to us, it would be really helpful for me to answer. Okay, I would give time to Tanmay and proceed on to the next question. Any online links or materials you can share, Surabhi? Hey Surabhi, I would absolutely be sharing all the links which I have bookmarked in my Chrome browser and which have been really helpful for me in all these while. So yeah, don't worry for that. I would be sharing them with you guys. Okay, Tanmay has rectified his question. Can we use data analytics for existing sites having millions of records and only having SQL used for statistics? Oh, absolutely, Tanmay. Trust me, the previous organization that I was with, the client that I had, they had no big data infrastructure setup, and we used to only rely upon SQL for the few months before we suggested them to onboard the data infrastructure onto their organization. So yes, you can do that. SQL can be useful for statistical measurements if you have millions and millions of records. Just that it would be slow. I mean, I don't want to get into that part right now because SQL can be really slow at times. So again, it depends on how your data engineers have set up the environment. But absolutely, you can rely on SQL for statistics, and that is what people in India are mostly relying upon because SAS is a paid software. Not everybody has an expertise on R. SQL is something that as computer science students, people end up learning. You end up using SQL in your applications, in your softwares. So SQL is having a relatively, easier learning curve for data analytics. So absolutely, SQL can be used for it. Okay, I have another question from Manzur who says how we can prepare for getting into Google. Okay, this is an interesting question. I would keep this for the last because, I mean, yeah, I understand everybody eventually wants to get inside Google, but let's keep that discussion for the last, is all I would say for now. I would move on to the next question, which Neha is asking me. How should I analyze myself? Whether I should go for data scientist as my career? I am a .NET developer having 1 year of experience. Okay, Neha, this is one of the questions which lots and lots of people are asking themselves today because with the recent developments in the IT industry and with lots and lots of people coming into the IT industry, I think people have started realizing now that there is a world outside IT as well. And that is when the next big thing, which is data analytics, comes into picture. So if you are a .NET developer with 1 year of experience, my understanding of you is that you would be having fair enough good amount of idea in software development and how to code at least. So all you need to do before judging that you want to go for data science as a career is read up on case studies, solve some case studies which are available online. I would be attaching a link to the website which has n number of case studies. Read up on that and like practice this thing of answering those case, solving those case studies, and then compare that what the solution for the case study is as suggested by other folks. So at least that would give you a very clear understanding of whether you have the business reasoning, the business aspect of becoming a data analyst or not. Because business sense, understanding business problems is a very critical aspect of becoming a data scientist. So yeah, just make sure that you solve those case studies, and then maybe because that would be a very good exercise for you to even understand that are you interested in solving such problems or not. Because it could be very well the reason that you are only interested in creating softwares and you don't want to solve all these business problems. You want an MBA guy to do it for you. So it then doesn't make any sense for you to switch to data scientist. What you can instead do is switch to become a data engineer, like grow your career as a data engineer, because that would coincide with your interest in the field of development, like software development and all. So yeah, I have one question from Surya who's asking, is data science all about writing algorithms to analyze data? Okay, Surya, data science is absolutely not all about algorithms to analyze data, because if you remember, I mentioned in the slides that data science as an industry has 3 branches. Data analytics is the part which is all about writing algorithms to analyze data. And this is a phrase, I would complete this. The complete statement is writing algorithms to analyze data and giving actionable insights to the company. So that is what is data analyst, at least the data analytics part of data science. Whereas data engineer is again what I just mentioned to Neha's answer. So yes, data analytics is essentially about writing algorithms and analyzing data, and then coming up with insights for companies to implement on. And this is very exciting because the coupons that you see, the very initial set of companies which used data science, Amazon was one of the companies which was using this in disguise, because that time people didn't know of something called data analytics or data science industry. It used to be called as business intelligence. It's just that it has been rebranded today with more focus on data than any other time. So what Amazon used to do is, and Amazon is a industry leader in suggestion engines. So if you buy something on Amazon, you clearly get, okay, people buy X thing with Y thing, or n number of people buy XY combination. How did they come up with this? This was using data analytics. They wrote algorithms. They used that algorithm on that data which they collected from people individually, and then they gave actionable insights. And they saw a surge in their sales figure because of recommendation. So I remember like 2 years or 3 years back when I was buying a television for myself, Amazon was intelligent enough to detect that the television doesn't comes up with a stand, like a wall stand, and it recommended me in the purchase page that, hey, people are buying this thing with this thing, would you want to do that? And I ended up buying it. So imagine the sale that happens. So there was an active sale of a television happening on their website, and there was a passive sale of a television wall stand which happened because of I getting that recommendation. So they were up marketing the other products using products which you ended up buying. So yeah, data analytics is very, very interesting, and I don't see any company which can survive without making sense of the data that they are collecting. This is what my understanding is, at least now. Okay, I have one last question from Tanmay before I go back to answering the how can I prepare for Google question. So Tanmay, your question is, most people learn big data nowadays. Also, it is also mandatory to choose data analytics as career path. Okay, big data is the craze word right now. I am pretty sure, because I remember when I was in Bhubaneswar for my engineering, I used to see hoardings and posters of Apache Spark. I used to see Hadoop. I used to see big data. I used to see Pig. I used to see Hive. All of these fancy posters put up in the entire Bhubaneswar. Now, what people fail to understand is, by learning all of these, you are becoming a data engineer and not a data analyst. So that is what the basic difference is. If you want a career in data analytics, learning big data would help you, but it is nowhere required for you to become a data analyst, because not every company uses Hive, not every company uses Hadoop. It totally depends from a company to company basis. So SQL is something which is standard. Eventually, all of these are SQL technologies. All of these are query-based methodologies. So if you master SQL, you can then build upon it and then kind of navigate your way through any language that you talk about, any framework that you talk about today. So no, big data is not a must if you want a career in data analytics. Okay, I would be taking in just one last question. So this question is from Ashutosh, who says, data mining, BI, warehousing tools like SSS, and for presentation, SSRS should be enough. Also, Power BI, how much R or SAS makes difference when I can do slicing and dicing of my data in SQL tools? Okay, Ashutosh. A very good question here, because I clearly see that you have an understanding of all of these things already. So Power BI, Tableau, ClickView, all of these are business intelligence tools which essentially help you visualize data and help you present that data. You need to understand what the difference is eventually. R or SAS will make a difference. At least R would make a huge difference, because let's say you want to do something like which I was speaking earlier about sentiment analysis. You want to understand that, okay, Royal Challengers Bangalore is losing a match in their home ground. What do people feel about it? Now tell me, is it possible for somebody to go to every fan and ask, hey, how are you feeling? Hey, what do you think Bangalore lost today? No, right? You can't do that. Whereas what you can rely on is people tweet a lot. and people vent out their anger most of the times on Twitter. Like there have been instances, right? We all would agree that some customer care of some random company isn't responding to us. We would go to the Twitter handle and tag them and say that, hey, you're not looking into my problem. Imagine all of these such tweets which a company is getting that, hey, people, you are not looking at my problem. They can do text mining on it. They can understand what the sentiment of a person is based on the verbs that they are using, based on the figures of speech that they are using. You can write algorithms, and all of these things can be done in R, because R is an open source software, and it allows people to upload packages onto the library. So there's this organization called CRAN, which maintains the biggest library of R, and they host all of these packages. So maybe all you have to do is clean your code, create columns for your clean your data, create columns for your data saying that, okay, date is this, on this date I got this tweet, this date I got this tweet. Just have two columns maybe, run the package, the text analytics package, the text mining, the sentiment analytics package, which is there in R. Like there are n number of those packages in R. Run those packages on this data, and then come up with a word cloud saying, okay, this word for a 1 month period of time has been used the most amount of time. So, if somebody says, okay, you guys are pissing me off, imagine pissing is the word which comes out clearly in the word cloud. And you as a company, you as a marketing manager, or you maybe as a CEO, how easy would it become for you to understand that, okay, people are clearly pissed off with my product or my company. So that is how R is useful. Now, how about doing this in SQL? The answer to this is very clear. You would have to write all the codes yourself. There are ways to do this, but you would have to write a hell lot of code, which is already done in R for you. So that is how it makes the major difference when it comes to using these softwares and selecting which thing to use when. You might just get deprecated in years to come, because there are lots and lots of other technologies which are coming up. There are companies which are creating softwares for data analysts. So yeah, my understanding is that you cannot rely on SQL for doing all of these things. Okay, that comes to a closure on the questions that I just got. But before I hand it over to Saurav, I would surely take up the question. I'm just finding out who asked those questions. Okay, it's Manzar who asked me how we can prepare for getting into Google. Manzar, you would get lots and lots of answers on Quora, but based on my personal experience, if that is what you're expecting me to say to you, trust me, I didn't apply for Google at all, and neither was Google a company which I looked up to in terms of having a career here. It's just that I happened to be at Mu Sigma, got to work with very nice people on very nice and innovative projects, and I had my LinkedIn profile updated, which is still updated. I mean, I make sure that after every project that I work on, after every skill that I learn, I do make sure that I go ahead and update my LinkedIn profile. So one of the recruiters from Google, kind of approached me on LinkedIn saying that, hey, we are interested. And that is how I ended up becoming a Googler. So I don't think I can suggest you any way on how to prepare for getting into Google, because there are people with me who have joined and we haven't been processed through the conventional process of sending the resume to a Google recruiter and then having interviews, lots and lots of interviews, and then joining the company. So to help you, my idea is I wouldn't give you my suggestion, because maybe I would be misleading you or misguiding you, which I obviously don't want to do. So I would absolutely leave it to you to go ahead and search for this question on Quora, because Quora has lots of Googlers who have answered this question. So just that, my only suggestion would be, don't restrict your career to only learning what is there in the UGC curriculum, which is prescribed for you. The world is beyond that. That is not even 1% of the world. That is not even relevant to what you would be doing, irrespective of whether you become a data analyst, whether you become a software developer, whether you choose any profession. That is not the world at all. The world is like amazingly different when you join a corporate life. So yeah, that would be all. I would pass it on to Saurav now. Hey Saurav, are you there?
Yeah, I'm here.
Yeah, cool. I would pass it on to you now. I'd put myself on mute.
Sure. Okay. Can you see the screen? Can you see my screen? Hello? Oh, yeah. Okay. Thank you, Ankit, for giving the opportunity. You have really answered the questions well. And so, as you know, we are running out of time, and we have also reached the end of the session. I would again thank Ankit. It was really insightful talk and was very, very informative. I hope you all have found it interesting as well. So, as I've said earlier, that you can also ping us anytime with any of the questions, and we'll try our best to answer all of them. You have you can see the screen here. You can join us here. The Twitter handle is here. You can ping us on Facebook, and here is the Indian Mentor website. You can also follow this. So I'll be sending the feedback form. So guys, please fill up that so that we can improve in our further upcoming sessions, and stay in touch. Happy learning. I would like to thank all the participants and organizers of MSTC Odisha for joining in and support for the success of this webinar. Thank you all for joining. Hope to see you soon.